This is Algebra Lesson 4-5, writing a function rule. Now, many real-world functional relationships can be represented by equations. You can use an equation to find the solution of a given real-world problem. So today we're going to look at real-world problems and writing function rules for those so that you could solve them if asked for a different variable, or excuse me, a different value than the one you started with. So, a landfill has 50,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of waste. What is a functional rule that represents the total amount of waste after m months? So we need to relate that the total waste is 50,000 tons of waste plus 420 tons of waste each month times our number of months. So the first thing we need to do is we need to define some variables. So let's let t equal our total waste. Okay, and we're going to let m equal our number of months. So I basically need to write an equation from this. Since we know that the total waste is 50,000 tons of waste plus 420 tons of waste each month times the number of months, our total waste then will equal our 50,000 tons of waste that we already started with plus 420 tons of waste per month times the number of months that we have waste. So it ends up to be 50,000 plus 420 m. So there is a function rule for that specific real-world problem. So now I could figure out how much waste is in the landfill on any number of given of months. If I said I want to know how much waste is in the landfill in 12 months or in 18 months or in 36 months, I can just use this function rule and I will know how many tons of waste they have in the landfill at that time. Writing and evaluating a function rule. Okay, well, last time we just wrote the rule. Now we're going to write it so that we can actually evaluate it. So an archery club charges an annual membership fee of $65 plus $2 every time you visit. Write a function rule for the total cost of belonging to the club if you make V visits in a year, and then you're going to use that function rule to figure out how much it would cost you if you use the club 15 times in a year. So I need two variables here. Okay, I need my total cost, and they already gave me V being my number of visits. So I'm going to have those two variables. I'm going to let C equal my cost. And V is going to equal my number of visits. Okay, so I know that my annual membership plus my cost per visit times my number of visits should equal my total. Okay, so my total cost, C, should equal, my annual membership is $65. I have to pay $65 whether I use the archery club once per year, 100 times per year, or no times per year. So I'm going to have to pay $65 just to be a member of the archery club. And then it's $2 for every visit. So that's going to be $2 times every visit, which is 2V. Okay. So there is my function rule. I found my function rule. My function rule is C equals 65 plus 2V. Now I need to evaluate my function rule if I use it 15 times in a year. So now I'm going to replace V with 15. So C will equal 65 plus 2 times 15, which is going to be 65 plus 30, which ends up to be 95. So it will cost me $95 to visit 15 times. So there we go. We have evaluated our rule. We made a rule. So here was our rule right here. And then we evaluated it for 15 visits. And then we know that it will cost us $95. Okay. Both of these rules that we just made were linear rules. They were a linear function. It would be a straight line function on a graph. Now we're going to talk about what happens if we have a non-linear function rule. It says write a function rule for the area of a rectangle whose length is 3 more than the width. What is the area of the rectangle when the width is 7 inches? Well, we have to have two variables. Okay. So we know that it says find the function rule for the area of a rectangle whose length is 3 more than the width. So the length is being compared to the width. So I'm going to let W equal my width. And since my length is compared to my width, and my length is 3 more than my width, then W plus 3 is going to equal my length. Now, if you remember, area of a rectangle, area is found by taking your length multiplied by your width. Okay, so I'm going to multiply my length times my width. So my area will equal my length, which is W plus 3, times my width, which is W. So when I go to evaluate this, I have to distribute the W through there. W times W is W squared. 3 times W is 3W. So my area is found by taking the formula W squared plus 3W. And this is not a linear function rule. This is a non-linear function rule. So we've written our function rule. Now we need to find out what the area of the rectangle will be when its width is 7 inches. So now I'm going to substitute in 7 every time I see W. So A is going to equal 7 squared plus 3 times 7. 7 squared is 49, plus 3 times 7 is 21. So my area is going to be 49 plus 21, which is equal to 70. And of course, it's in inches, so it would be square inches, because an area is always in square units. So my function rule is right here, W squared plus 3W, and then when the area of the rectangle is 7, what is the area when the width is 7? The area is 70 square inches. Written inches squared, always spoken square inches. And there we have a non-linear function rule. Simply what you're doing is you're defining your variables and writing an equation, but this happens to be a function versus just any old other equation. So we've been doing this for a long time. Should not be new to you. And our closure question for this lesson, which I lost. There it is. Is it necessary to create a table of values for a real-world situation in order to write an equation that represents the function? And explain. And you should be able to explain that one pretty easily. And you should be able to answer it pretty easily.